Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering 8.5. 8.5 is looking at arc length and radian measure. So just like the last few sections, it's a little bit much. It's a lot crammed into one section. If we were in person, we'd be taking a few days on this, but because we don't have that luxury, we're just kind of trying to get as much in as we can, so bear with me here. Again, like I said, there's a couple things we're going to be covering. This is going to really require you to have done your Unit 7 material and Unit 8 material so far. So if you haven't done that yet, I would recommend starting with that first before you try to do 8.5. With that said, we'll go ahead and just jump right into it here. So, as everything is in Unit 8, we're looking at circles. And the first thing we're looking at, if you remember from Unit 7, we said that there's this idea of a unit circle. The unit circle being a circle that is drawn about the origin, and specifically it's a circle that has a radius of 1. So it's a circle that is going through the origin, assuming this is drawn to scale, of course, and then that circle has a radius of 1. So regardless of where that radius is drawn, whether I'm drawing it here, whether I'm drawing it here, the radius around the circle is 1. Now, if I were to calculate the circumference of this circle, that would be pi times diameter, which if the radius is 1 times 2 times pi, would give me a circumference of 2 pi. Now, I've mentioned this before, that there are other ways that we can measure angles, and so this is what we're starting in today, where it says radians. Radians is another way of measuring angle measurements, specifically based in the unit circle. So the idea of radians is using this unit circle, saying that if we go all the way around, that's 2 pi. Okay? So because of that, we are going to define 2 pi as how we would measure it in degrees, which is 360 degrees. Now based on that, if 2 pi is 360 degrees, then 1 pi, half of that, would be 180 degrees. And so the first thing you're asked to do in 8.5 is to be able to convert from either degrees to radians, and most of them are pretty straightforward. If you have a unit circle handy to you, or if you have like an older sibling that's done this before, more common angle measurements will be written into the unit circle, so you'll have 30, 45, 90, etc. But if not, then there's always a way to convert between the two for any measurement. So for instance, if I give you, say, 270 degrees, and I ask you to convert that to radians. So if you're going from degrees to radians, you're going to use this conversion factor, and you're going to multiply by pi over 180. So if I give you degrees, 270, and I ask you to convert it to radians, you're going to multiply that by pi over 180. And then you would simplify the fraction. This is 270 over 180. And it may take you a few steps. You can cancel out the zeros to give you 27 over 18. Those are both multiples of 9. So you end up with 3 pi over 2. Like so. If you're asked to go the other way, radians to degrees, then you'll be multiplying by the reciprocal, which is 180 over pi. So if I gave you, let's say, pi over 4, and I asked you to convert it to degrees, you'd be multiplying that by 180 over pi. In this case, the pi's will cancel out, and 180 divided by 4 gives me 45 degrees. We'll be doing more practice with these in class, but just for now, that's how you convert degrees to radians, radians to degrees. That's something you need to be familiar with. Now, in your section also kind of tacked on is this concept of what's known as a coterminal angle. So a coterminal angle is an angle that, as the name might imply, terminates at the same spot. Co-terminates. So usually when we're looking at an angle measurement, we're used to starting at the x-axis, going up and saying, okay, well, whatever that measurement is, let's say I take out a protractor, that's the measure of my angle. So let's say in that example up there, let's say that's
Turner.
30 degrees. There are an infinite number of coterminal angles to this. There are an infinite number of coterminal angles to this. Coterminal means that it ends up at the same spot. So, for instance, if I went around more than once, let's say I went around and then back up, that is a coterminal angle. So going around is 360 degrees, plus that 30, that would give me 390 degrees. And the same would be true if I went around more than once. Let's say I went around twice and then ended up there. That would give me a measurement of 2 go-arounds, so 360 times 2 plus 30, that's 750 degrees. So you can continue to go around and around and around. As long as you end up at the same spot, that's a coterminal angle. Okay, so that's also tacked into this. So you have your degrees to radians, you have radians to degrees, you have this idea of coterminal angles, and then the other part of this section is arc measurement. Specifically, arc measurement, not arc length. So sometimes we refer to an arc in terms of the degrees of the angle in which it's encompassing. But here we actually want to know what the distance of that line is. So here's basically what you have to do for this section. If you are given a circle, okay, and a radius, let's say the radius is 4 inches, for instance, we could solve for the diameter no problem, right? We could solve for all the way around. Circumference is pi times diameter, or 2 pi r. So we can find all the way around. With arc measure, our goal is to be able to solve for just a part of that. So let's say I had an arc that was 90 degrees. We'll call this AOC. So if I want to know the length of arc AC, I would need to use that angle measurement to be able to determine what part of the circumference that angle is. Now that we're using radians, we want to be doing this in radians instead of degrees. So 90 degrees ends up being pi over 2. Okay. So that's our angle measurement here. And there's a couple ways you can do this. If you were doing it in degrees, we know that a whole circle is 360. So 90 out of 360, that is 1/4 of my circle. So rather than going all the way around, if I just wanted to know what this length was, AC, I would take the whole circumference and times it by 1/4. So the whole circumference, pi times diameter, would be 2 times 4 times pi, so 8 pi is the circumference. If I want to know the length of AC, it would be 1/4 of that.
Turner.
So 1/4 times my 8 pi, which would give me 2 pi, like so. Super brief.
Hey, does anyone know how to use the to do a graph table on freaking on that one thing decimals?
I will talk to you soon. Bye.
Press